I think I've mentioned it, have I not? That if you need additional time, you want to learn Python skills pretty quickly or catch up to the people who had it under Python 1113, then there are online sites that have tutorials. Specifically, there's one called Solo Learn. Did I mention that one already? You can go to sololearn.com. You log in with a Google account or Facebook if you feel like trusting Facebook with all your data. And then there's a Python 3 tutorial. Be a really good thing to do if you're not feeling real comfortable with Python, right? Stop it already. The first applications of computers were to crunch numbers. I would take some dispute with that, but not a lot. The dispute being is that the Americans tended to build the computers during World War II in order to improve weaponry, which is numbers, but the English did it in order to crack codes. And you know, those are text messages, and yeah, there was still a lot of math involved in that. But anyways, so we use computers to manipulate numbers, text, and nowadays a lot of other things, right? You know, music files, graphical images, things like that. Ultimately, all of those are stored as numbers as well. So in real life, the range of numbers is infinite, right? You can have an infinity of numbers, which is a weird concept because you also have an infinity of odd numbers and an infinity of even numbers, right? And so is the infinity of all numbers greater than the infinity of odd numbers? I don't know. Anyways, they say that and I don't believe this, I think there's a typo here, that the possible values of an integer, I did start the recording, did I not? Yeah, that the possible values of an integer, negative 21 to the power of 31 to 2 to the power of 31, nah, that 1 is erroneous, right? That's still a large number, huge number. If we come up here and do 2 to the power of 31 and look at a result, that's a great big number. 1,000, million, billion. I think it can hold numbers larger than that, actually. I think that we have proven that, maybe even in this individual class. If I do A is equal to, and I'm going to type in a number in the trillions, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, and then I print out A, works. So I don't know why they say in this particular slide that those are the limits of an integer. That would be the limits of an integer if it used 32 bits to store its data. Anyways, what we need to know about an integer is that it's a floating point it's an integer value. It's whole numbers only. And if you need to hold gigantic values, you would probably, well, no, never mind. It holds large numbers, right? And if you need integers, you can specify that you want an integer. What do I mean by that? What if you have a floating point number, A is equal to 3.14159, and you want it to be an integer? Well, right now it's not. If I do a type A, it tells me it's a float. I could do this. I could say convert A into an integer. We've seen that syntax when we did float, right? A is equal to float A. Kind of nice for it to be able to do that, right? And then now it is a whole number. The type of A is an int. Honestly, I don't foresee needing to do that a lot, but you can. Something a little bit more useful is, what if you have a number like this? A is equal to, I'm just going to make something up. All right, that's got a lot of decimal places in it, etc. What if you wanted it rounded off to 4 decimal places? I'm not sure that this is a good example. Let's find out what happens. If we do round A to 4 decimal places. Okay, well that's because it was a very small number. Let me pick a better example. Right. There we go. Right. And now, if I print it out, it looks like that. Notice we lost a little bit, right? It went to 758 and then it truncated the rest of this. That's floating point rounding error. We only have a certain amount of space to hold a floating point number. And when I say we, the language does, right? Because pi goes on infinitely. But we cannot store infinitely large numbers on the computer. And so the floating point type does have a limit to the precision, about 16 digits of precision. So you can use the round statement to make things look prettier, right? If I do this, print round A to 4 places, great. Or what if I actually did want to round that number? A is equal to round A comma 4, and then I print A out and it's equal to 1.4, right? There are other ways of doing rounding for output, and I may have already shown you them, where you do the print, but you use the placeholders like %s and %f. Like if A is equal to 1 point blah 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 blah, and you want it printed out to 2 decimal places or 1, print %.2f, %.2f. Now print out A. The syntax is very particular and looks a little bit different. If you've seen this syntax in C or Java, there was a comma there rather than a %. But what this is saying is fill in this placeholder. The % is the placeholder, and this is the formatting for that placeholder with the value of A, but it obeys its formatting. F means that it's going to have a decimal point. It's a float, but the 0.2 means round it to 2 places. So we get 1.23. There are other ways of doing that as well, but I always forget them. Dot format. And I forget the way the placeholder looks on this. Pardon me for Googling an example of Python string dot format. Seeing if I can really spot one fast. No. Nope, that's the other style. The style that I'm trying to show you now was added, oh, for Pete's sake, was added in Python 3, and all the examples we're seeing are still using the other style. All right, so if you're going to do the dot format style, you enclose the placeholders in curly braces, like this. So print and fill that in with dot format of A, like that. Well, that doesn't specify, how many decimal places, but we can do that as well. A little example I believe showed that. 9.3f means make it 9 characters wide with 3 places devoted to the decimal point. I believe if we leave the 9 off, it would still have 3 dedicated to the decimal. So print :0:0.2f end quote or end parentheses dot format A, like that. And I blew it up. I needed a closing brace there. This is why I shouldn't be editing things in a shell. Needed a closing brace because this is a placeholder here. I don't have a good argument for using this syntax other than the other one. Except maybe you hate seeing that % sign there. What if we had 2 numbers we wanted to print out? Right, print. Here's placeholder 0, or the first one in the series. Computers always start counting at 0. Here's placeholder 1. And we wanted them each to be 10 characters wide for some reason. And then here's our data, dot format, Joe, Roberts. It's going to format each one of those into string to fill up 10 spaces, right? If we counted, that's 10, and then this is 10 more. And if you wanted to right justify them rather than left justify, you could do that. Just mentioning this. We'll hit this over and over, but honestly, I always revert back to this because I remember that syntax better because I learned it 30 years ago as a C programmer. And so once you learn that, you can use it in other programming languages. However, C# follows this one, so, you know, yeah. Whichever one you like. Or whichever one the book teaches, which I do not recall. So a floating point number can hold up to exponent 308, which is a number followed by 308 zeros, right? But the numbers are actually stored in exponent format. It's time to go ahead and create a new file. So my name, February 12th, you know, scripting, 1203, chapter 2. Okay, so I'm going to do a quote, quote, quote in order to just start taking notes. If you have this number, it doesn't get stored like that. It gets stored as an exponent format. Scientific notation, 4.5434355356, whatever, right? Not sure that's right. And then how many zeros is it going to have? It's going to be 10 to the what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's equal to, you know, times 10 to the power of 9. Or more succinctly, right, like that. We've seen that notation before. So a certain number of bits are dedicated to that. A certain number of bits are dedicated to that. That's why there's a limit, you know, 16 digits. Now, honestly, that's not the full story because everything has to be, you know, converted to binary, powers of 2 in order to be stored. And there are some numbers, some fractional numbers in base 10 that cannot be evenly stored in base 2. And so there are some numbers, some fractions, point something, that once stored as a floating point number and then brought back to be printed out in base 10, it gets rounded off wrong. That's called a rounding error, a floating point error. And I don't have a good example to give you. I need to give you one. Just be aware of the fact that when you're dealing with floating point numbers, they are not exactly correct. So you wind up doing things like this. I'm going to say A is equal to, and I'm going to type in some number, right? 2 point, blah, blah, you know, right, whatever. Say that was a result of my calculation. And then I wanted to check its value, right? If I do this, A is equal to whatever, you know, am I going to do that? That is kind of lame. Why do I mean that's kind of lame? If it's even a little bit different. Floating point numbers are not as precise as integers, right? With an integer, you know it's either a 2 or a 3. But with rounding errors, you can't really guarantee that that's equal to that. If you've taken a physics or chemistry class, you're used to the idea that you take a measurement, right? But your scale is only, you know, accurate to like 3 or 4 or 5 places or something like that. So what you should do is check to see if it's within a certain range. And we haven't even learned about the OR statement, but I'm going to go ahead and show you that range anyways. And I forget what I should call it. So I'm just going to use the word, I forget if it's called sigma or what. How about diff? The accuracy. I want it to be accurate within 1/100th of a thousandth. So what I do is I take this number and I subtract the answer from it, like this, and I see if that difference is greater than this specified difference, right? So in this case, A minus that number is going to be exactly 0. Else, now I'm going to change this a little bit in just a little bit. Else, print the same. I'm going to change that 2.0000 business just to 2. Is this lecture D or E? D as in doggy. Alrighty. So it says they're not the same because it's not close enough, right? What if I made it a little bit more accurate, but there's a problem. We may need the absolute value. Honestly, if I don't recall if I can just type in ABS. Yeah, that works right there. We need the absolute value because what if it was a little bit larger than 2 or a little bit smaller than 2? Still says they're not the same, but if we increase this accuracy, right, like that, it's definitely going to say that they're the same or that they're equivalent or not. What if I make this exactly 2? Let's follow my logic first. Make sure that's exactly 2. Make sure I don't make any dummy mistakes. I'm getting a feeling that there's a dummy mistake involved here. So how about 2.1? That should be close enough for that difference to count. All right, I'm failing on this, and I don't know why. Oh, because, of course, 2.1 is way too different from 2 to be counted as the same. What if we were allowed, 0.5, right? A 0.5 difference is okay. 2.5 is an acceptable answer. 1.5 is an acceptable answer. Now it's considering them to be the same, right? Even though, 2.1 is not exactly what we're looking for, it's close enough. So when you're doing comparisons of floating point numbers, you got to check them just to see if they're close enough rather than precisely exactly the same. That's just a programming technique to tuck away in your head, and we will see it later. I'm going to rewrite this just a little bit more to see if I can make it make sense and put some comments on it, and then we won't broach this again for a while. I'm going to say that this measurement of a minus 2 is the delta, right? The difference between the two values. So delta is equal to the absolute value of a minus 2. And then if the delta is greater than the allowable difference, they're not the same. Maybe I'll call it allowed difference, permissible difference, some term like that. And the actual mathematical term for that is escaping my brain. And that's one of those things where I've changed it 20 times in a row, and you guys who are typing the notes in are annoyed at me. I apologize for that. I'm going to have you all watch a video that I taped for the other class, so I'm going to be skipping a little bit of this stuff. We'll mention a few things, though. Do remember the order of operation, precedence. PMDAS. PMDAS. Parentheses get evaluated before anything else. And then multiplication and division. And then addition and subtraction. Right. And if you've used a scientific calculator where you can type in a whole long thing before you hit the equal button, then you're used to these ideas already. So if you have this equation, a is equal to 3 plus 4 times 5. What do you do first? Do you do the addition or do you do the multiplication? Right, you do the multiplication. So it's actually equal to 3 plus 20, right? Because 4 plus 5 is 20. And then that's equal to 23. If there were parentheses involved to change the order of operation, like this, then you would do that part first. So that's a completely different thing. 3 plus 4 is 7, and then times 5 is equal to 35. Right. Now just because M comes before D does not mean that you look at the equation and go and find all the multiplications first and then all the divisions. They have the same priority, so you just go left to right. So if you add this equation, A is equal to 10 divided by 2 times 5. You don't go, oh, I better do all the multiplication first because M becomes before D, and so this is all wrong. I better not type this. 10 divided by, whoopsie, 10 divided by 10. Is that what that equals? No. We should have done the division first, just because it comes first in it. So when you're talking about things with the same precedence, the same priority, then these are equivalent, and you just do them left to right. Same for addition and subtraction. I'm going to rewrite that to say, 5 times 5 is equal to 25. So, I forgot one. Exponents. The reason I forgot it is some languages don't have an exponent operator. Java and C# don't. But this one does. Pardon? It's annoying. Here's what you got to do. Here's what you got to do. This is Java. Well, let's do it in Python first. A is equal to 3 to the power of 4. That's Python. Java. A is equal to math.pow 3, 4. C# or C++. A, okay, you got to do two things. # include, angle brace, CMath, and you really don't have to type all these notes. This is for a language that we're not even learning, but it was a good question. And then you can do A is equal to POW 3, 4. CMath does it, I believe. I believe you get the POW function by default, and we're not going to spend more than 10 seconds talking about it. You get the POW function by default for Microsoft C, but not for Linux or Mac, and so you have to # include CMath to get it. Alrighty, and so that's how you do it in Z++, right? You have to actually bring in a library to do it. That's how you do it in Java. Annoying. I like having the exponent operator. I think that, lots of languages should do it. Just don't do this in any language. That's not going to do it. A is equal to 3. That's how we typed it, right? That's how we learned to type it, but that's not any language I've ever seen. That makes sense? Yeah. All right, when the operands of an operator are of different types, then they get converted to be the same type. And this is almost a little bit too computer science-y for me to want to be babbling about. But I'll give you an example. If you do this, A is equal to 3 divided by 4, and I don't believe this. I think this is a bunch of hooey. I think that slide needs to be deleted. I'm going to prove it to myself. I'm going to come here, and I'm going to get back to the shell. 3 divided by 4. The slide showed that it would equal 0. The slide's wrong because that's not for this language. That's the C programming language. Cute. All right, onward. That really aggravates me, though. The reason it really aggravates me is I don't remember if on the unit test they asked that question, but it's completely wrong. Here's what they're saying, is that if you do 3 divided by 4, the result is an integer. Now that's true of Java and C++ and C#, whereas 3 divided by 4.0 is a fractional amount. That's true. Not in this language. All right, there. Now I feel better. I'll upload that. Somebody who writing this textbook copied a lot of it, or at least these PowerPoints copied something from another programming textbook, and that wasn't valid. Yeah. So the int function, which I mentioned, truncates, meaning it drops the value to the nearest closest value. So if I did this, A equals the integer version of 3.9, it's going to say the result is 3. But if I do this, A is equal to the rounded version of 3.9, it does a proper rounding, right, where 0.5 and above go up, anything under 0.5 goes down. result is for. Which do you care about? Well, I guess it's up to you to pick which one you want to use when you want. And do remember that if you specify a second number, it'll round it to a fractional value, right? So if you do a is equal to round of 3.333331, like that, the result is going to be 3.3, right? Because it preserves one decimal place. All right, this is good stuff, so I'm going to go fully here. Python includes many useful functions which are organized in libraries of code called modules. This is a different use of the term module than they used it in fundamentals. In fundamentals, the textbook called every function its own module. We're not going to use that term module again in that sense. We're going to use the correct term for just about every programming language I've ever used, and I disagree with that textbook. A function is a function is a function. We're writing functions. So what is a function? It's a chunk of code that can be called by a name to perform a task. Well, let's add a function to our code. It's going to be a dumb function. But I need to close my notes with the triple quote, and I'm going to define a function, and it's going to be called wow. So def wow, open parentheses, close parentheses, colon, and then print. Oh, wow, man. End quote, end parentheses. And then if I want, I can call wow as many times as I want. So it's going to print that message 3 times in a row. Now it's stupid. Well, I won't say it's stupid. It doesn't provide you much of an advantage to wrap a single line of code in a function, right? Because I could have just done this, right? Wouldn't have taken me hardly any more typing. But if it's more than one line of code, yeah, it can certainly make sense, right? What if we're calculating pi, or we're performing some calculation and it takes 10 steps to calculate that value? You would not want to repeat those 10 steps everywhere in the code that it was going to happen. You'd want to just write the function once and then call the function in order to do it. Functions can take parameters. Excuse me, I botched that. Functions can take arguments. Arguments fill in parameters that are defined inside the parentheses. So we will write a function that takes arguments. We're going to write something called add3, def space add3 parentheses x comma y comma z in parentheses colon. Here's what we're going to do after that. We're going to add x, y, and z and store them in a variable called r for result. R is equal to x plus y plus z, and then return r. X, y, and z are parameters. A parameter is a variable that accepts a value from the function call. So when we call add3, we better fill in a value. So that x is a variable, it will contain a value that we send to it. Y will be a variable, it will contain another value. Z will be a third variable, it will accept the third argument in the function call. So print parentheses, add parentheses, 10, 20, 30, a closed parentheses and another closed parentheses. So 10 plus 20 plus 30 is going to be 60, I hope. What happens? This 10 gets copied into that variable, so x is going to equal 10. That 20 gets copied into that variable, and that 30 gets copied into that variable. When you're calling it, the pieces of data that fill in the parameters are known as arguments. Now those terms are so similar in your brain that you'll, or at least in my brain, that I'll make a mistake. I'll say, okay, these are our parameters, 10, 20, and 30. Technically, they're the arguments that fill in the parameters. just kind of roll with it. And if you remember that distinction when I make the mistake, you can kind of chuckle in your sleeve at how stupid I am. Then I'll know I made a mistake. Anyways, you know what I mean. The terms are almost synonymous in my brain, but the arguments are the things that fill in the parameters, and the parameters are variables. We can pass in other variables into here in order to fill them in. So anyways, I'm going to put that 10, 20, and 30 are arguments. Now I'm going to print out something else. Add 10 plus 20. Do I have a variable defined yet? I'm going to delete that momentarily. X is equal to 100. Y is equal to 200. Z is equal to 300. Then I'm going to do the same kind of thing, the same kind of print of an add. Print parentheses, add parentheses, X comma Y comma Z. End parentheses, end parentheses. Oh, and I made a mistake. I've made two mistakes. Or I repeated my mistake. Can anybody see here? Right, what's the function name? Yeah, it's add3, and here I'm just calling it add. So you need to correct yours. If you copied along faithfully, that should be add3, and this should be add3. The function name has to be the same. All right, and so 100 plus 200 plus 300 is in fact 600. Here we are seeing that the x is filling in this x, the y is filling in this variable, and the z is filling in this variable. Now the fact that their names happen to match is just pure coincidence. I could have called it ABC and filled them in like that. Now Python does something called pass by copy or pass by value, meaning that x is copied into this variable. This variable and this variable are not the same. It's a subtle distinction, but I'll show you what I mean. What if before we return out of that function, we set x equal to some silly value? We zero it out for whatever purpose. If we came down here and printed out x like that, we might expect it to print out 0. Why? Well, we passed x in there, and then all of a sudden x is getting reset to 0. No, these are two completely different variables. This one just contains a copy of the data I passed it. It's like I'm going to a mailbox. But instead of me putting the original letter in the mailbox, I make a Xerox copy of it, and I give it a Xerox copy. I was pointing at the wrong thing. This is a mailbox. We're passing in a Xerox copy of it. And so, yeah, if it tears up the letter or whatever, I still have my original data. So just because this is setting this equal to 0 does not change the value of this variable. That variable gets copied. So that's called pass by copy or pass by value. So when we print it out, it's going to say 100 and not 0. I'll just put a parenthetical note here. Python and Java, for you guys who are taking Java courses, are pass by copy / pass by value languages, meaning that the value is copied into the parameter. Changing the value of the parameter does not change the original data. Changing the value of the parameter does not change the original data. Now there are times when it looks like it does. When we get to lists, it looks like it's the same variable, because you could pass in a list, which is what's known as an array in your other languages, and then you can make changes to the list. Makes it look like I'm a liar. Makes it look like it actually copied, didn't copy the list into it, like it actually passed it in, and they're the same. But it's still different, and we'll get back to that. Just trust this for now. Some languages give you a way to circumvent this functionality. C++ and C# allow something called pass by reference. And C++ also supports something called pass by pointer. Both of those are ways to get it so that when you pass a number in here, you actually could change it. If you set x equal to 0, then by the time it's done and you get back out here, x would in fact be 0 with those languages if you do something special. But Not true of this one. How many of y'all are taking another language besides Python or have? Like you've done Java, you've done C++. Okay, yeah. So it's not completely meaningless if I start mentioning other languages. So some functions are built in, like ABS, absolute value, and round. Then there's a module called math, which gives us a whole bunch of other functions. Now you always just see me use 3.14159 for the value of pi, but we could include the math module and then get that. Normally you put your imports up at the very top of the code, but I'm going to put it here just because this is where I am. Import math, and then say I have something with a radius of 10 and I want to figure out its area. So it's pi r squared. So area is equal to pi, which is, I typed in uppercase M, but it's not. Math dot pi times 10 to the power of 2. Yes, I should have used a variable, to hold the radius. This is the key component of it. I'm not digging the fact that they're saying you have to use an uppercase M there to get the square root, and they're saying that you use a lowercase m to get that. One or the other is true, not both. So, import math, math.py, math with a capital M, .py, kaboom. Alrighty, how about that square root function they're talking about? Math.sqrt, parentheses, the square root of 100 is 10. How about we capitalize it like the PowerPoint shows? Boom. Okay, not a mistake. At least I can correct this one. It's not in an image. All right. I want my money back on this PowerPoint. Sorry, guys. All right. Anyways, you can get the square root of a number without importing a math library, as long as you have exponents available to you. In those other languages where you have to import a library in order to use them, then you may as well use a square root function. But this language allows you to just do this. 100 to the power of 0.5. Any number to the power of 0.5 is the square root of that number. If you want to take the cube root of a number, it would be 100 star star 1 over 3 in parentheses. That's the cube root of 100. The 10th root of a number would be 100 star star 1 over 10. Just a shortcut. But if you have the square root function available to you, which you do if you include the math library, then feel free to do that. Now your homework assignment involves using the square root because it calculates the hypotenuse. Pythagorean theorem, I guess. The square root of a squared plus b squared gives you the length of the hypotenuse. So you have to use a square root. In the video, I demonstrate doing it like this. And in the homework assignment, I specify doing it like that. If you want to be awesome and cool and use a math.square root function, totally cool. I could modify the instructions to mention that you can do that as well. All right, say you hate typing in math dot everywhere, right? Here I'm at to get square root function to work. I'm going to go back and put this in the notes, right? Say I don't want to precede everything with math dot. Maybe that looks cheesy to you. You can do this. From math, import pi. And now you can just do area is equal to pi times 10 to the power of 2. Same thing for square root. From math, import sqrt, right? And then a is equal to sqrt, parentheses 100, instead of doing A is equal to math.sqrt, which would still work because we have that statement there. I'm going to go and modify my code here under that import math just to show the square root function so that we can see the distinction between the two ways of doing it. Because I did on the shell, but I did not do here in my code. So I'm going to come back up here underneath that one and do A is equal to math.sqrt, parentheses 100. What if you want to get all the functions rather than list them line by line, right? I mean, there's one, there's another one, but the math library is huge, right? Sine, cosine, tangent, arctan, and radians, and all sorts of different functions. So if you want to import them all in that syntax, you can do this. From math, import star. Bring in everything. That does the same thing that this did, except it allows us to skip using the math.business. And that works for any library, not just the math library. So that allows us to skip typing math dot in front of all the functions. The main module. I'm skipping that slide. Running a script from a terminal command. This is really useful if you can do it. If Python is in your search path and you're using a PC, this will work. What's not going to work great for your Mac users. You have to do so in a different way. But if I come to the search box, I type CMD, I get my command.exe going. If I type in Python and it shows me that it ran Python, great. I'm feeling good. I can run things from the command prompt. To get out of it, I typed exit parentheses in parentheses, or I could have just closed it. So if I had a Python file in that directory, I could run it. You don't necessarily have to do this, but I'm going to find a Python file. And the way I'm going to find it is, let me blow up the size of this console window so you can see what I'm doing here. Right. I'm going to do dir space asterisk.py, search subdirectories, and only show the file names, not the associated information. I'll show you the difference. Well, if it ever comes up. Yeah. If I do it that way, it's showing all this information, but if I tack on to /b, it brings it down to the bare bones. So, inside this directory are some scripts. So if I'm careful, cd desktop, cd CIT1213, and then I want to run this jan22.py file, I would type in Python space jan22.py, and it would run it. Well, whatever was in that day, right? Joe, Bob, and so on. So yes, you can run Python from the command prompt. When you installed Python, hopefully it set it up so that you could do so. Now on the Mac, when you launch a terminal window, Python already comes installed on the Mac, but for some reason, Apple in their infinite genius installed Python 2 on all the Macs. And so when you install Python 3, it still leaves Python 2 because some of the guts of the operating system, or at least the utilities, written on to work on it, rely on Python 2. And I don't recall if I've mentioned this, but the syntax between Python 2 and Python 3, they're not compatible with each other. A lot of code works, but a lot of code doesn't. If you take up something written for Python 2 and you try to run it in Python 3, there may be differences. You install Python 3 on a Mac, great, you can use it, you launch idle, you can play with it all you want, but if you open a terminal on a Mac and then try to run it, I'm not sure which it's running, whether it's running Python 2 or Python 3. I have a vague, disturbing memory of it being Python 2. Who's got a Mac in here right now? Give it a shot. Open up the terminal. Just go ahead and type in Python and hit enter. Yeah. My statement is true. Even though he's installed Python 3, it's running Python 2. And I'm sure that there are ways of fixing that. You could Google it if you wanted to. That's really frustrating, though, as far as I'm concerned. Doesn't mean Macs are stupid. It's nice that it's installed to begin with, right? Macs are cool. They're almost just a different form of Linux. That they use very similar terminal commands. Almost, except it's not open source. Alrighty. So running a script from a terminal command. That is just what we did. Maybe not we. You saw me do it, right? You saw me go into that directory, find some Python files, and then I was able to run them by typing Python space lecture and then the file name. If I double click on a Python file from the Explorer, it probably is not going to do what I hope it would do. What I would hope it would do is launch idle. Instead, it runs it. Now, that's good behavior, too. I like the idea of being able to run my programs. But if it runs some Win version of Python, WinPython or Python Win, that's extraordinarily frustrating. You can fix that by going to Lecture B, open with, and picking a different program to open. Browse and find the Python executable. Might have to go to some trouble to find it, but find a Python executable, and then you can make it so when you double click on it, it runs Python, rather than launching WinPython or something bizarre. Somebody will do that. Somebody do that. Open up a window, go into your code directory, and then just double click on a py file. See what it does. I know what it'll do for you. It'll run it. I think, right?
Should. So you want to open with or just run?
Just run it. Just double click it.
Yeah.
Yep. And so it ran it. Okay. In another classroom, I was seeing it run some bizarre WinPython thing. Okay, it's working for y'all. Awesome.
It opens mine next code.
Okay, and it didn't happen in yours. But you could configure that. You know how to configure it. Yeah. Okay, that's good. That is good behavior, but frustrating because you download your script, you want to edit it, you double click on it, no, it's not editing it. And I think I've mentioned that before. Go into idle and open it from there, or right click and see if edit with idle is available as a choice. The 32-bit version doesn't seem to work, so I'm going to pop open a 64-bit, and boom, I'm editing it inside of idle. We've talked about comments. In fact, we're in the chapter summary. I don't see much reason to hit that, to say that line by line. Here's another place where I beg to differ, but a lot of textbooks skip saying this, and I believe I've said it before. The textbook says that there's two different kinds of errors. No, that's close enough. There are three kinds of errors. There's syntax errors. Then there are logic errors. A logic error is, the code runs, but it gives you the wrong result. You're supposed to calculate pi and it comes out 0. Logic error. And this says a semantic error occurs when the computer cannot perform the requested operation. That's actually known as a runtime error. And other textbooks will say that a logic error is called a semantic error. I don't know why, the programming gods can't all, get their act together. So a runtime error is when it crashes, right? You try to open a file, but the file doesn't exist. The computer cannot perform the requested operation. You divide by 0 and your computer crashes, that kind of stuff. They're calling that a semantic error. I would call that a runtime error. I like calling that a logic error, though. That's good. Now, I'm going to kind of recap those things just a little bit in my notes, since I'm okay with calling it a semantic error, but I also want to give you my term for it. And just know that if you walk into another classroom with another textbook, they may say that a semantic error is something else. Okay, so errors. In fact, I'm going to do quote, quote, quote just to start off. There are syntax errors, typos, mistakes in grammars, that kind of thing. Then there are logic errors. Program runs, but does the wrong thing. Whatever the wrong thing means, right? You suddenly find out that your character can walk through walls. That's pretty cool, right? You can take advantage of it, but it's a bug in it. It's a logic error. And then they're saying a semantic error, I'm going to put parentheses, runtime error. Program cannot do what it is told. Usually crashes at that point. I'm sure you've all had the exquisite joy, if you're a Windows user, of seeing it pop up the little message that says program has performed an illegal operation and will be closed. You don't get a chance to save your word, right? It's just boom, it's dead. Unfun. Now, Windows programs aren't the only ones that can crash like that, but that's the one I see the most often. You can code things to try to avoid runtime errors. And I'm going to show you how. I'm not expecting you to have this memorized yet, but why not stick it in your brain if you can. All right, I'm going to end this with some triple quotes. What if we have an operation that is doomed to fail? Like we have the numerator and the denominator. So numerator is equal to 3, denominator is equal to 6, and we're going to say the fraction is equal to num divided by denom. And then print the frac. Print parentheses frac in parentheses. And it's going to run. It's going to be pretty cool. It's going to print 0.5 because 3 divided by 6 is... Okay, what if 6 was a 0? It blows up. Division by 0. The program crashes. Now, for our little silly programs, that's okay. If you're writing, software that controls a self-driving car, or a Mars lander or something like that, you don't, a jet plane, you don't want your computer crashing. So, you can fix that. You can capture runtime errors by doing this. Try colon. And then put everything indented under it that is risky. And then when you're done with all that stuff that is risky, put the word except, E-X-C-E-P-T, colon. And we're going to print an error message. Print, oops, divide by 0. End quote in parentheses. And then I'm going to print a done message here, just to show that, the program didn't crash. All right. So it caught it. It did not fail. As we go along, I'm going to be doing try and except anywhere where I think that the program might crash. And when I say that I will be doing so,
I will be encouraging that, but I may not be writing it like that every single time, right? Because it took additional time to do it, but it's good programming. You want to try to make your programs bulletproof. I'll give you another example.
What if we ask the user for a value? You know, A equals input parentheses quote, input a number, in parentheses, excuse me, end quote, in parentheses. And then we do A equals float parentheses A, right? Great. Then we could do something with it, right? We could square the value or do something like that. If I run it and then I type in 10, 5, whatever, great, it did it. If I type in a bad piece of data, input a number, but I type in something else, it yells at me, could not convert string to float. That's another runtime error. The book calls it a semantic error. You can catch that mistake just like you could catch the divide by zero mistake. This is the riskiest statement. This is the one that can blow up. That's the one that you would need to put in the try block. So try, parentheses, try, colon, and then on the next line, tab, A equals float parentheses A. But if something blows up, we have to catch the error. So except colon. Now what are we going to do here? The cool thing to do would be to keep looping, making them type in good values until they finally get a good one, right? But that's introducing loops. I'm not going to talk about loops yet, so here's what I'm going to do. I'm just going to print an error message. Print invalid input defaulting to 1.0. End quote, in parentheses. And then I'm going to set A equals 1.0. And then just to prove it, I'm going to do print parentheses, quote, A equals, end quote, comma, A in parentheses, just to show that it worked, right? So we can see that it works with whether we give it good data or bad data, right? Input a number. I type in a good number. Cool, A is equal to 100. Input a number. I'm going to type in a bad number, like 100y, right? Invalid input, defaulting to 1.0. So at least it didn't crash. If it's acceptable to default to some other value, great. Usually what you would want to do is loop, right? At the worst, you would want your program to exit gracefully, right? Not with a red text, right? You know, display a nice, friendly error message, and then, you know, quit the program or ask the user if they want to run the program again, something like that. Okay, so your homework could be pretty easy. We have written programs where we use the input statement, correct? Homework. Rewrite an earlier program to use try except to catch bad input. Assign a default value if an error occurs, just like we did here. I don't care if you default to 0 or 1. I think I would default to 1 because, you know, if you're doing like a rectangle or something like that, or, so, you know, a circle, a radius of 0. That will be our homework. Now I want to show you something else before you run out. I'll just take roll based on what you upload today, so make sure you upload something into the Dropbox. Here's the lecture that I want you to watch. It has a little bit of overlap from what we talked about today, but not much. And so by giving y'all this lecture, y'all are now ahead of the other class, but that's because you skipped a little, right? And so this is going to fill in the stuff that we didn't talk about very, very closely. Some stuff. Here's the assignment. The Dropbox is called Paper Calculations. So if you come out here to Homework 3, Paper Calculations, watch the video and review the notes for the lecture, then do the assignment. Now, honestly, you could probably do this homework without watching a video. but still kind of want you to watch the video, right? So just follow the link, watch the video, you know, come back and read the lecture notes, which is just everything that I typed in the video, and then go ahead and do the homework, which will probably maybe take you like, 5 minutes, but man, some people it takes longer. If you struggle with it, let me know, right? Ask for help. That makes sense?
Are we doing two homeworks or are we doing the?
We're doing two, right? Those are actually two separate assignments.
Can you go back to the original, where you typed in the Python?
I sure can. I sure can.
I didn't get that.
That's going to be homework 4.
Okay.
Whoops, don't launch Java. All right, so homework 4 is rewrite an earlier program to use try except to catch bad input, and then assign a default value if an error occurs. Whatever you think is a reasonable default value. So, to let you wait until the weekend to watch the video, I didn't make the due date Monday night on that homework. I made it Wednesday night, right? So you get some extra time, and if you have questions, you can come and ask me, in class on Tuesday. They can get it done on Wednesday night. That makes sense? More than a week to get that one done. This one will be due on Sunday. But as always, I'll give you a day's grace period, so if you have to come in and ask a question, you can do that. Any questions?
Do you have Lecture D already up in assignments? Is that for the online lecture or is that the...
The online lecture, I don't care if you upload any notes. I thought about it, and then I decided that would get way too confusing, so I'm blowing that one off. I trust you to watch it. If you don't watch it, hey, whatever, right? So that Lecture D is what you want to upload today's notes into. Good question. So this is Dropbox D. A lot of y'all have already found it. Go ahead and upload today's notes or a note saying that you were here.